going to use elimination to solve this. So the first thing we need to do is make sure the equations are lined up so we have one term with opposite coefficients. And if you look here, I've got my first equation where I have plus 6y, and then I have my second equation where I have minus 6y. There are my opposite coefficients. And the reason I want to have opposite coefficients is because when I add these equations together, they will cancel out. So I've got my opposite coefficients for one of my variables. So there's step one. Step two is just to add the two equations together. So I'm going to add these two equations together, which just basically means combine my like terms. 4x plus 3x is 7x. Positive 6y minus 6y gives me 0y, which you don't even need to write that. You just know it's going to be 0y. But if it makes you more comfortable, you can write 0y there to start. And then 32 plus 33 is 35. And notice, when I simplify this, because 0y is just 0, I get 7x equals 35. Then I just need to solve this for x. Divide each side by 7, and I get x equals 5. And at this point, we've done all the new parts. We've used elimination. Now it's exactly like substitution. I'm going to take my answer, and it doesn't matter which equation you go and plug it back in for. You get the same answer. I'm going to take it and plug it back in for the first one. 4, I'm going to plug in 5 for x, substitute that value in, plus 6y equals 32. Now I just need to solve this equation. 4 times 5 is 20, plus 6y equals 32. Subtract 20 from each side. I get 6y equals 12. And then I divide each side by 6, and I get y equals 2. And then remember, you always write your final answer as an ordered pair, 5, 2. So notice, everything I did over here was exactly the same as substitution. The only part that was new was finding these opposite coefficients, which we found so that the variable would cancel out when we added the equations together. Then we solved for our variable that was left. After that, plugged it back in, just like in substitution.